In this problem, we're going to use this grouped frequency table to find the sample standard deviation S. We're given a formula in order to do this. And we're told that X is the class midpoint, F is the frequency that you see here, and N is the total number of sample points. The standard deviation has been computed earlier from just the data points, all of the data points in the sample, not using this group frequency table. So we're going to compare the two at the end. Remember, the reason for this channel is to help you pass your math class so you can achieve your goal and get a better life. Finding the sample standard deviation using the group frequency table coming right up. Remember that X is a midpoint. Let me calculate the midpoint from 30 to 39. So I just take the average. 30 plus 39 divided by 2. Of course, that's going to give me 34.5. So 34.5, and then let me square that. So 34.5 squared, and that's going to give me 1,190.25, and I can go ahead and calculate that all the way through. Next, I'm going to do F times X squared. So 2 times 1190.25, and that's going to give me 2380.50, so 2380.50, and finally I have just X, 34.5, times F, so 34.5 times 2, and that of course is just going to give me 69, and I can go through and fill out each one of these columns. I'm going to need all of these for my formula. So after we've completed this table, we've filled in the table, we need to be able to figure out or calculate all the different values so we can use them in our formula. And you'll see here I've got the formula written right here, and we see that N is equal to 89. So when I add up all the frequencies, that's 89. And this symbol right here is the Greek capital letter sigma, and it means the sum, as you probably remember. So when I have the square brackets and then F multiplied by X squared, that means I've got to take the sum of F multiplied by X squared. So I've got to take this value and add it to this value, add up all these values, and this is the result. So the sum of F times X squared, and notice I'm doing the multiplication first and then adding them up, is 292,172.25. And finally here I want to get the sum of all just the F, the frequency, and the midpoints together. So I don't do the square there. So I've got to do the multiplication first and then add up. So what I have there, that sum is 5,030.50. And now that I've figured out all of that, I can actually plug into my formula. So now I can plug into my formula, so I know S equals overall square root, and I'm just going to do the whole numerator first. So I have 89 multiplied by a really big number, 292,172.25, or I can think of that as a multiplication, minus 5,030.50, all of that is squared. So all of that is the numerator, And then in the bottom I have 89 times 88. N minus 1 is 88. And notice, by the order of operations, what I have to do is I have to square this and then multiply this and then subtract. So don't forget order of operations. So we can do that one on the calculator. So I'm going to say second square root, and I'm going to put everything in the numerator in this first parentheses. So it's 89 times 292,172.25 subtract 5,030.50 squared, and all of that is the numerator, divided by, and then I'm going to put the entire denominator in parentheses, 89 times 88. Close the parentheses. I'm going to click this forward arrow to get out from under the square root and hit enter. And there I can see that my calculated sample standard deviation is 9.436, 9.44, and if I wanted to round this to a single decimal place, it's 9.4. And you'll recall the overall standard deviation, not calculated from the group frequency, was 9.0. So my next task, I need to compare 9.4 and 9.0 and see if they're within 20% of one another. My final task is to compare the directly calculated sample standard deviation of 9.0 with the calculation I just did from the group frequency table, 9.4, and I'm told that a difference of 20% is significant. So what I need to do is I want to take 9.4, the calculated one, and divide it by 9.0, and I can do that on my calculator. When I put that into my calculator, I get 1.044, and I subtract 1, and I change 0.44 to a percent, and that is 4.4%. That is less than 20%. So I calculate that the difference between the two standard deviations is not significant. They're close enough, in other words, not significant. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.